All right, so let's move on to problem 2. Just solved problem 1, part A and B. Let's look at problem 2 here. So problem 2 is simple. They give us a graph, and we're asked to look at this graph, and we're asked to answer a few questions about it. So let me just draw the graph roughly here. We have an y-axis, we have an x-axis. Always label your axes. This is negative x, negative y. Okay. And we're told that this is the point 1, 2, this is x equals 2, 3, 4, x equals 4. We're also told that this is the point y equals 2. Alright, and then we're given a graph here. Oh, this is the point. It's not labeled, but this is y equals 1. Okay, down there. So we're then showed a graph of this function where at x equals 2, 1, we can see visually that that's the bottom of our graph. This is the point 2, sorry, this is negative 1. 2, negative 1. We have the bottom of our what is known as a parabola, if you're wondering what that shape is. And we can see that we also have an intercept here at x equals 3. We have an intercept here at x equals 1. And we also have an intercept here, if we look, at y equals 3. Just right here. So let's fill in the blanks. What we actually have is something that looks something like this. Sorry, that's not perfect. And we are asked to answer some questions about this graph, okay? So we're not given any equations. Excuse me. We're not given any equations. We're just asked to determine if the graph is a function and explain how, for part 1. So what did we learn? We learned that we can do the vertical line test. So let's do it. If we draw a vertical line, will it ever pass through a function more than once? And the answer is no. See? There's no point I can draw a line, and I don't want to mess up our graph too much. There's no point I can draw a line where it passes through the function more than once. A vertical line where it passes through the function more than once. So, therefore, it is a function. It has passed the vertical line test. Now, if you won't need to explain yourself, which you will need to explain yourself for this part, you would say this is a graph of a function, and the reason is because it passes the vertical line test, i.e., for every x value, there is only one unique y value, meaning at x equals 3, for example, the only y value is y equals 0. And at x equals 0, right here, the only corresponding y value is y equals 3. Now, you'll notice y can equal 3 for a different x value, just so long as that x value has only one unique outcome, okay? Like y equals 3 here, and y also equals 3 here. This is just saying that there's two x values that correspond to the same y value, that's okay. Again, it has to do with a singular x value. Does that x value correspond to more than one y value? If the answer is yes, then you're screwed. Okay, but if that's confusing, just forget about that part, and just remember that for any x value, there can only be one y value for it to be a function. And you'll simply have to put that into words to explain your reasoning for this problem. And you were also asked to state all of the x and y intercepts. So an x-intercept occurs at the point where the function passes over the x-axis, this line here. X-intercept occurs at y equals 0. The y-intercept occurs at x equals 0. So what's the value of our function when y equals 0? Well, y equals 0 everywhere along the x-axis. This is the area where y equals 0. Right, this y equals 0 if you're on the x-axis. And so what are the x values when y equals 0? Well, here we have x equals 1, and here we have x equals 3. So the x-intercepts are x equals 1 and x equals 3. Or more formally, you could say the x-intercepts occur at 1, 0 and 3, 0. All right, what about the y-intercept? Now the y-intercept, since it's a function, we should only have one, i.e. when x equals 0, there should only be one value of y. And that value is x equals 0 all along the y-axis here. So when x equals 0, what is the value of y? Here we can clearly see y is equal to 3. So we can do it like this, y equals 3, or we could write the y-intercept occurs at 0, 3. Make sure you always explain what you're saying. I'm not writing down everything because it takes a lot of time, but when you're answering a problem like this, always write it down. So that's the answer to problem, or part 2, question 2. Now, you were asked to find the state, the domain, and range of your function. Okay, so what is the domain? Let's remember the domain corresponds to all of the allowed x values, while the range corresponds to all of the allowed y values. Now what you'll notice is that our graph of our function was given to us with these arrows. This means that it's continuous. This is a continuous function. It is not discrete. There's no discontinuity, is what they would say. And because it's a continuous function, what we can say is that for all of these given x, so what are the possible allowed x values of our function? If we were to continue on this way, what would be the domain of our function? Well, assuming it goes on to infinity, we would basically bottom out at x equals negative infinity, okay? And in this direction, we would bottom out, and it clearly is going to be a very slow process if we were to really do this, but we would bottom out at x equals positive infinity. because all of these are allowed values for x, meaning this is actually, I mean, if you know anything about parabolas, this is y equals x squared. What are the possible allowed values for our x squared? Well, this isn't quite that. This is a shifted parabola. But there's no restrictions. There's no accidental division by 0 here. If we let x equal negative 1 billion and we let x equal positive 1 billion, it's still defined. Is it defined out to negative infinity and out to positive infinity? Yes. So the domain is negative infinity to positive infinity. Now, I have these open brackets, or these curved brackets, because this means that it includes the endpoints. We'll talk about, there's an alternative type of bracket you can have, which looks something like this, and this means something different. But let's take a look at the range. So this, again, this is our x values, possible x values. What is our domain? What about our range? The range is all of the allowed x value, y values. So here we can see, if we look at our function, it goes on to infinity, but where did it start with the y values? There's no spot below y equals negative 1 where we have any defined y values. So that's anything below y equals negative 1 is outside of our domain, outside of our range. So we're going to be starting at and including, that's why we have this square bracket, negative 1, and we go up to positive infinity, because again, like, this is just asking you what are the possible y values that we could ever possibly find. And as we can see, they just get, from negative 1, they get continuously more positive out to positive infinity. Same on this side. Starting at y equals negative 1, they just get continuously more positive. If you were always to draw an arrow back to the y-axis, ask what the value is, it would be somewhere between negative 1 and positive infinity. So we are including negative 1. Now, if this was resting just above negative 1, then we would have this round point. I may have misspoken when I talked about the brackets here. This does not include the endpoints because it just doesn't. Infinity is infinity. It's not exactly real quantity. But if it includes the endpoints, then you put this square bracket. If it doesn't include the endpoint, then it just goes all the way up to that. And that's where you have the round bracket. I would look into, I'd watch another YouTube video on that if you're still wondering, like, what type of, ask ChatGPT, what type of brackets do I use depending on the endpoints, or the domain and the range, and they'll give you a better explanation. But essentially, this would be your range. And again, these correspond to possible y values.